Set theory, practice exercises number 54 through 61. So on 54 through 57, they're saying let set A have elements 1, 2, 3, 4, 5. So as you can see, there are 5 elements in that set. I'm going to go ahead and write the cardinalities right below. Set B has 3 elements. And set C has 2 elements. So I'm going to use all of that to answer these questions. So when they have N, and then in parentheses A, they're saying how many elements are in set A. Well, that's easy enough to answer, so that's 5. How many elements in set B? That's 3. Okay, when I'm talking about the number of elements in A union C, recall that I can see that we have 5 elements in set A, 2 elements in set C. Now, have we counted something twice? Yeah, we have. So I'm going to subtract from that what they had in common. So the cardinality of the union of sets A and C is just 6. Okay, the intersection of sets A and C is just 1. As we just mentioned, they only have 1 element in common. Okay, so the Venn diagram here shows the cardinality of each set. So we're going to use this for 58 through 61 to find the cardinality of the given set. So when they're talking about the cardinality of A intersects C, they're talking about this entire region right here, okay? So that's going to be 4 plus 1 clearly, which is 5. Okay? Let me get rid of that. Okay, and then when they're talking about the cardinality of the union of B and C, they're talking, oops, probably saw that one coming. They're talking about this whole region here, B union C. So I'm going to be adding the 3 and the 5 and the 1 and the 2 and the 4 and the 8. So I don't have the answer to that real quickly. So I'm going to cheat and look in the back. 23. I hope that adds up to the same thing. That would be embarrassing otherwise. Okay. And then on 60, we need the cardinality of the intersection of A and B, and then the complement of C. Well, I'm going to go ahead and number my regions so I know what I'm talking about. So 1, 2, 3, 4, 5, 6, 7, and 8. So the intersection of A and B would be regions 2 and 5. And so I want to intersect that with the complement of C, which is regions 1, 2, and 3. So the only thing that they have in common as far as the regions is region 2. So region 2 has the cardinality of 3. Okay. All right. So for the next one, I want the intersection of A, the complement of B, and C. So I'm going to erase just this mess that I made here. Okay, so A, of course, would be regions 1, 2, 4, and 5. I want the intersection of that and the complement of B, which is 1, 4, 7, and 8. So the only regions that they have in common are 1 and 4. So then I want to intersect that with C, which has 4, 5, 6, and 7 regions. So again, it looks like the only thing they have in common here is region 4. Okay, so let's look at the cardinality of region 4 right here, and it just coincidentally is 4.